Okay, so now in this video I'm going to demonstrate the client auto reconnection feature. Like if a client is connected to the queue manager, the active instance of the multi-instance queue manager, and somehow due to any possible reason, if the server goes down, the queue manager goes down, then the client must be then the standby instance would become the active queue manager, and the client should be able to reconnect it automatically. So to demonstrate that, we have a test. We'll be using the same servers, 3 servers, and the MQ client is installed on the host Windows system. MQ client 7.0 is installed, and we'll be using 3 client sample application programs, high availability application programs, that are AMQS PHAC, AMQS GHAC, AMQS MHAC. Now AMQS MHAC is a client application program that puts a sequence of messages to a queue with a delay of 2 seconds. AMQS MHAC is a client application program to move messages from one queue to another queue, and AMQS GHAC is client application programs which gets the message from the queue. So now what we're going to do in this test is that we'll define a local queue named source in the active queue manager instance for named PSAP, and we'll define a local queue, another local queue named target, and we'll define the client channel, and we'll provide the client on the Windows host with the client channel definition table, that is CCDT, and then we'll start putting messages using the client high availability program, that is AMQS PHAC, and we'll move the message, and we'll use AMQS GHAC to get messages. In the meanwhile, what we'll do after starting all these sample high availability applications is that we'll shut down the server hosting the active instance, and it will approximately take 7 minutes or less for the application to connect to the standby instance, which will have become the active instance. So to demonstrate that, first we'll switch user to MKM, and we'll get into the queue manager control area for PSAP. We'll define a local queue over here, name source, we'll define another local queue over here named target. Now we'll define a server con channel, we name it channel 1. Okay, the spelling is wrong. Define channel. So here the channel is created, the server con channel, and now we'll create the client connection channel. The same name, sorry, now in con name we'll give the IP of both the systems, both the servers. That was 192.168.1.9 and 1.10. We'll give the listener port number. Here the default port number we are using, but we can give any port number to the listener using the define listener command. The second IP would be 192.168.1.10. Same default port number is being used. Then we give the QM name, that is PSAP. Okay. Channel created, was a space problem. Now we'll start the channel. Channel 1. Now we'll define the listener. Define listener. We name it listener.tcp. And control QMGR, which means that when the queue manager will come up, the listener would come up automatically with the queue manager. So we have defined the listener called listener.tcp. Now we'll start the listener. Start listener listener.tcp. The listener has been created. We'll just has been started. We'll just see the status of the listener. Listener.tcp status. It's running, and just to confirm, we'll see that control has been set to queue manager. Yes, it is. So once we'll see the channel. Here it is. The second one is the client connection channel 192.168.1.9, port number 1414, and the other IP and the default port number. Now this one is your server con channel. So the configuration is done for this queue manager. Just to verify that this is running as active instance. Yes, it is running. Now what we did over here, we defined a client connection channel. What it does, it writes into a file which is known as the CCDT, the client channel definition table, which is named amqclchl.tab. This client channel definition table, this file is copied onto the client machine, and this CCDT is used by the client to connect to the MQ server. So first of all, we'll copy the file from the server. Here I have WinSCP. We'll provide the host name, that is 192.168.1.9. Login as root. So we go on to the Red Hat machine server. Just give read and write permission. Otherwise we will not be able to copy the file. So the amqclchl.tab is found in cd /mq export /qmjrs qmjrs. This was the path that we specified for the MQ data files. Queue manager name is psap, and the file can be found in this directory at ipcc. We do an ls-ltr. See, here we have got amqclchl.tab. We'll modify the permissions. Having done that, already there. We'll replace that. So we get into MQ export, QMGRS, PSAP, IPCC, and here it is, MQCLCHL.tab. We'll just move it over here. We'll copy. We'll overwrite the existing file, and we can see that we have the file on a local system. So now we'll open our client. So first of all, we'll just do this PMQ where. So this is running 7.0.1.3. First of all, we'll unset all the environment variables. Set MQ server, which we'll not be using in any case, but we'll unset it. To unset it, we'll just set MQ server to blank. We'll set MQCHL lib is equal to blank, and we'll set MQCHL tab is equal to blank. So we had to unset these so that, just to make sure that it does not pick up the old values that may have been defined on the client. So we'll set the environment variable, set MQCHL lib to the path where we have copied our CCDT file, MQCLCHL.tab, and we will set MQCHL tab equal to AMQCLCHL.tab, the name of the client channel definition file, which has been set. Now, just to verify, before using our client availability sample high availability applications, we'll verify that our configuration is correct or not, and whether our client is able to connect to a server or not. So we use AMQS put on MQ server, we use AMQS put on MQ client, we use AMQS put C to put messages to the queue that we created, and we give the queue manager name PSAP, and here we are able to put message. We'll not put any messages as of now. We'll just quit the sample application, and now we'll start another command prompt just to make sure. We'll see that the environment variable are set. Yes, they are. So over here we'll start the sample application AMQS PHAC that will put messages to the source queue with a delay of 2 seconds. So AMQS PHAC, we'll give the name of the queue and name of the queue manager PSAP So it started to put messages. We'll open another command prompt in which we will start the sample application to move the messages, which is AMQS MHAC. We'll give the name of the source queue, that is source. We'll give the name of the target queue, that is target, to move the messages, and we'll give the name of the queue manager, that is PSAP. This application is also started, and we'll start another one for getting messages. So now sorry, AMQS GHAC, and we'll mention the name of the target queue, that is target, from where the application has to pick up the messages, and we'll get the name of the queue manager, that is PSAP. So it started to get messages. You can see one application is putting messages, one is moving them to the target queue, and the third one is picking up the messages. So what we do over here to test our configuration, to test the client automatic reconnection, what we do over here, now this VM, it's running the, so we'll clear it once, and we'll do a DSP MQ -X-O standby, which will show that it is active. It's running an active instance on this server, and it's running as standby instance on the another server. So in case of any disaster or any problem that the server goes down, the client must be able to reconnect it to the standby instance, which would become the active instance. So what we'll do over here, we'll just shut down this VM completely. We'll shut it down. Yes, it has shut down, and you can see the events on the put application and the get applications. Connection reconnecting. The connection has been lost and is attempting to reconnect to the standby instance, which would become the active instance in case the active instance has gone down. So what IBM says that it takes up to 7 minutes for the client applications to connect to the standby instance, which would have become the active instance. So the whole process can take up to 7 minutes or even less. So we'll wait for the standby instance to become the active instance and the applications to connect to it and start putting messages and start getting messages again. Here the connection has been established. It's the put application is putting messages again over here, you can see, and the get application would reconnect after some time to get the messages from the queue. Here we can see the MQSGHAC is trying to reconnect again. It's not necessary that all applications come up at the same time. See, now they just come up. It's getting the messages. We can just go into the Red Hat 2 machine. We do a DSP MQ. We can see that PSAP has become the active instance over here. To verify, DSP MQ-X-O standby. See, this instance has become active. In case the first server on which the active instance was running, which had the lock on the queue manager shared directory, it went down, so this standby instance became the active instance. This completes a demonstration of multi-instance queue managers on Linux, and also the demonstration of client automatic reconnection. The client automatic reconnection has also been demonstrated. So now there's some other considerations to be tested. That will there be any conflict if the queue managers running different versions of MQ, like one running 5.3 and the other one running 7? Would there be any conflict in that or not? So that will be part of the research that will be carried out. For now, signing off.